Number 23 is the second problem, talking about a mixture of gases that aren't reacting. In it, we have 5.23 grams of chloroform, CHCl3, and 1.66 grams of methane, CH4. The volume of the container is 0.0500 liters. The temperature is 275 Celsius, which turns into 548 Kelvin. And we need to find two things. We need to find the total pressure, and we need to find the pressure that is contributed by the chloroform. Now, unlike problem number 22, since I need to find both things, I'm going to suggest that the most efficient way of doing this is to use the ideal gas law to find out what's the pressure of the chloroform and what's the pressure of the methane. If I add them together, I'll have the total pressure. And along the way, I would have found what pressure came from just the chloroform. So before I can use the ideal gas law, I need PV and RT. Well, let's see. P is what I'm looking for, so I'm not going to find one of those. That's my question mark. V, T, my N is what's missing. R is the constant, so I'm missing N. So I need to find N, number of moles for chloroform, and moles equals the mass, so the grams of chloroform divided by the molar mass. Well, I know this. The grams of chloroform are 5.23 grams. And I use my periodic table to look up the mass of carbon, hydrogen, plus 3 chlorines. And I find the molar mass of chloroform is 119.37 grams per mole. So that will give me the moles of chloroform. And I actually don't need to find that number. I just need to use that number. What I want to find is the pressure that comes from the chloroform. And the pressure is going to equal nRT over V. So for moles of chloroform, I substitute in this. 5.23 over 119.37. For R, I get to pick my R. It can be any one as long as I'm consistent. Because I'd like to get my answer in atmospheres, I'm going to use 0.0821. T is 548 Kelvin. And down here under volume, I've got 0.0500. Plug this into my calculator, and I come up with the pressure from chloroform is 39.4 atmospheres. I do a similar thing, and this is one of my answers. What's the pressure from the chlorine? So that's one of my answers. To get my total pressure, I also need to find the pressure of methane. And that's going to equal the same thing, nRT over V, but now I need a term that determines the moles of methane. Well, it's going to be the same structure. The moles of methane are going to be the 1.66 grams of methane divided by the molar mass of methane, which is 16.04 grams per mole. And then that's going to be times, well, everything else will be the same. 0.0821, 548 Kelvin, all divided by 0.0500 liters. And that tells me that the pressure from methane is 93.1 atmospheres. Now that's not one of my answers, but I needed it. I needed it because my pressure total is going to equal the pressure from the chloroform plus the pressure from the methane. So 39.4 plus 93.1 equals, with significant digits, 133 atm. That's my other answer, the total pressure.